and we're all going to work on this together, is writing an equation to represent this area relationship. And this is the type of equation we're going to learn how to solve in this unit. That's why we're setting up with lesson 1. So everybody right now, the easiest thing to do is draw a picture of this in your notes. I've already got one on the screen, but you would really just need to draw a rectangle and a bigger rectangle. I like to throw out there, I know I'm a great drawer, so don't expect it to look as great as mine. Don't let it deter you from trying to make rectangles. Okay? Keep trying. I know I'm going to try really hard this time to make them a little better. Okay. So again, don't be nervous about my steady hand. Okay. So what we're going to work on here is establishing a few things. We already said that the picture was 7 by 4. So what's the area of the picture? What's the area then, Owen?
28.
And then we established that we had 2.5 by 4 for the border, which means the border has an area of 10, which means our total area is 38 square inches. So that's a good place to start. That area of our picture and our border totals 38 square inches total. So if I'm going to look at building an equation, my equation needs to equal 38. Everybody good with where we're at right now?
Yes.
So to build my area equation, what two values am I looking for? Micah?
Length and width.
Or base and height, length, width, right? So that's where we're going to run into an issue. We know that this part is 7 by 4, but we don't know what the border is still. What do we usually call things we don't know in math? X, or a variable. So I'm going to label it as X. That border is X on both dimensions, length and width, right? Right? It's the same thickness all the way around. Is everybody good with what we're putting out there? So I don't know how wide it is. I'm going to say it's X wide. Here's where we're making a little step. If I want the base, how wide is my base then?
Well, it's going to be something.
It is something. I know how much of my base for sure.
7.
I know 7 from the picture. And then plus the border. How much border is there?
Well,
There's not X.
Why?
No.
38.
I got 7 here. How much more to get this whole?
2x.
Yeah, 7 plus 2x. Everybody seeing that?
And then,
I've got border on both sides.
isn't that times 2?
Nope. Next, we're going to look at the height. I know the height has a 4 there. So what's this whole thing here? 4
4 plus 2x.
4 plus 2x.
Why can't it just be 7 plus 2x squared?
Because it's not 7 by 7. It's a 7 by 4 picture with the same border on both sides. So here's our function. This function says exactly the situation. Everybody, what's important is you understand where we got the 2x. It's x on both sides, right? On both sides. Everybody see that in the picture? So on the base, I've got 7, x, and x for 7 plus 2x. On the height, I got 4, I got x for 4 plus 2x. And I know that the total area is 38. And look at base times height equals 38. We've got the equation. So if I could figure out what x is, what would x tell me?
What little squares? What the length and width are of
The width. It just tells us the width of the border. But we could use that to then get the length of the border, right? We know we need to. Yep, because it has to be the same width all the way around. Perfect. Cool. Now, we do not have the skill set yet to answer this. What has this number equaled every time in Unit 6?
38.
No, in Unit 6.
Why?
Yeah, well, it's equaled 0 for the x-intercepts, or it's equal just like y or f of x, right? We have not put a number here yet. You guys, so if we would have seen this last unit, you guys know that it would look like this. 4 plus 2x equals, and we'd write like g of x or something like that. So we never put a value in here except 0 so far. We put 0 in there to find the x-intercepts, right?
Wait, but why can't we solve it like that?
Because it's not equal to 0 here. It's equal to 38 here.
Well,
for x.
Oh, well, you could, kind of, except when you distribute here, you're going to get an x squared, and we do not have the skill set yet to solve for something. Yeah, but when there's an x and an x squared, we don't have the skill set yet. But we could make it look like the other one. How could I get rid of that 38? Minus 38. We're not there yet. Just know that we're going to work on, that's what we're working toward. What I want to do to get you an answer, though, is look at it on decimal. So you guys cool with that, to see like what the actual answer is? So the goal of this lesson is to see, okay, there's a quadratic here that I can use to solve this problem. Now I'm not set equal to 0 anymore. I'm set equal to something else. We need new skills in order to figure this problem out. We don't have them yet, okay? So I'm going to get us over to decimals. And we had 7 plus 2x
And then 4.
and 4 plus 2x, and it equaled 38. So I have 2x intercepts here because this one does have two answers. Does negative 6-ish make sense for a border?
No.
Not for a border, so this has to be our answer. If, when you cut it out and tried things, and you got around 0.422, your border was a good border. So the width of your border.
Mr. Barrett.
Yeah, Bob. I don't expect you to solve this or anything right now. We understand that this answer to that quadratic, are we good understanding that area formula we made? Base times height was 38. And if there's two answers, the positive answer has to make sense, which means the width of the border that's perfect is 0.422. We're going to develop skill sets in this unit to solve, because really, well, there's more than one way. But I'll let you know, if I had this problem, I won't do the whole thing. But if I had that problem, I would probably look to do something like this. I'd probably look to do distribute first. I'll stop this for the video. We won't need this for the video. I'll just show you what you're going to look forward to knowing. Maybe I'll keep it in the video. It'll be fine. I've got 28 plus 8x plus 14x plus 4x squared equals 38. I would subtract 38 from both sides. And I'd have 4x squared plus 22x minus 10 equals 0. And then I do negative b plus or minus the square root of b squared minus 4ac over 2a. And if I did the math on this little thing here, the order of operations, I would get two answers. One of them being 442?
How can you get two answers?
No, 422.
422.
How can you get two answers?
Because when you square root a number from your warm-up, Bob, I love that you asked it. Square root of 9 can be positive or negative 3.
Oh.
Because of the square root. The two answers. A square. A quadratic.
Yeah.
Woo!
How will you know if it's positive or negative?
I'll teach you.
Can you go back to that?
No, you don't need to know how to do that.
I was just confused. You subtracted.
Hey, let's do the lesson summary together. What's the height at the start of the journey?
Well,
I'm going to hand this out to you in a second.
I can't tell if the question is true.
At time of 0, right? No, when time is 0, how high is it?
5.
5. This is 0.18, which is a random point. Okay, what's the height after 2 seconds? Is the graph better or the function for this? The function. So, we're going to put 2 into the function. Negative 16 times 2 squared plus 32 times 2 plus 5. Ooh, 5. And when does it hit the ground?
2.18.
Yeah, so this one we can't
2.1.
really use the function. I'm going to say ground at about 2.2. 2.15. I'm going to go 2.15 seconds. This is the thing. This is the part, y'all, where we need to build the skills to solve for t when there's two t's in there. That's what we're going to be working toward. That's why that's there. All right.